Bismillah Rahman Rahim. So today we will start chapter number 3, and chapter number 3 is regarding uninformed search algorithms. For your information, from chapter number 3 onwards, chapter number 3, chapter number 4, even chapter number 6, all these chapters are basically related to searching algorithms. Okay, all of these chapters are related to searching algorithms, and there are various algorithms which have been discussed in these chapters. And in this book, these search algorithms have been categorized. For example, one categorization is uninformed search algorithm. Second categorization is informed search algorithms. Another categorization is game-based search algorithm, or those algorithms which are being used in the games. So there are different categories of algorithms. So chapter number 3 starts with uninformed search algorithm. What is meant by uninformed? Then we will move forward. You know about search algorithms. Uh, First of all, in AI, search algorithms has a very important significance, because we are solving problems and we are looking for state spaces and we are searching for an optimal solution. So there is a lot of need of those algorithms, and also the advanced algorithms as well. We will see in the next chapters how we can use those algorithms in AI based problems. Why in AI based problems we are discussing these algorithms separately? Because जो AI based problems हैं उनके अंदर कुछ कॉम्प्लेक्सिटीज ज़्यादा होती हैं. मसलन हम एक नॉर्मल स्टेट स्पेस में नहीं होते हैं, बल्कि बाद दफ़ा हम ह्यूज स्टेट स्पेसेस में डील कर रहे होते हैं. So how we can reach out to our target state quickly, that is very important. So uninformed means that in these type of algorithms, sometimes we call them algorithms, sometimes we call them strategies. Same thing. Either you call it a strategy which is implemented in the form of an algorithm. So in uninformed search algorithms, we don't have extra information with ourselves. We don't have a clue of any extra information which is available to us. Only we have the given nodes and their connectivities. So normally we have the set of nodes and their connectivities. That's it. That we have, and with this information, what we have to do is we have to generate the algorithm and try to search out the node which is required. So we don't have any extra clue or any kind of heuristic to deal with such kind of problems. Okay. Basically, these type of algorithms are executed in terms of they're all called tree search algorithms as well, because all these algorithms are transformed into tree, and you have the basic idea of tree because you have studied various algorithms, search algorithms in your data structure course as well. So you have the idea of tree search. So whenever we talk about research in a tree, how we will proceed in a tree, we we have to have a base node from where we can explore the other nodes. So whenever we have such type of problem, we have to have the initial node. तो मेरे पास जरूर एक initial node होगी जिससे हम अपनी search को start करते हैं. And what is the next step in a tree? In the next step of the tree is to generate the successors. And what is meant by a successor? Successor means successor nodes are the nodes which are also called leaf nodes. So once you start the tree with any initial node, the next step is to try to generate the successors. And of course, that will be the next sibling. And when you generate the next sibling, then according to your strategy, you will move on to one of the nodes which you have generated, and then you will again generate the successors. That is the way we proceed in a tree. And how long we can do this thing? कब तक ये काम करेंगे जनाब? जब तक हम करते रहेंगे, जब तक या तो either we will get a solution or we get a failure. There are two possibilities in the tree search. We will move on to search on the desired node. If we get it, we stop over there. In these algorithms, whenever we reach to a solution, we stop over there. It means that node is obtained. So in tree algorithms or in all uninformed search algorithms, which we are discussing in chapter 3, always remember that the solution is not the given node जो आपने सर्च कर ली है, बल्कि solution is the path or you can say the sequence of states from the initial node to the goal node is basically is your answer. So whenever we have the solution, we try to generate the complete path from the goal, from the initial node to the goal node. So in tree search algorithms, you can see a function over there. A function is a tree search, which is you apply it to any given problem. And when I say you apply it to any given problem, it means obviously in any given problem you have number of states. Now it depends what type of problem you are dealing with. So there are various kinds of problems. For example, in chapter number 7, we have discussed the example of Wampus world. You can generate a tree for the Wampus world as well. You can generate a tree of, for example, if I ask you 8-number game in a 3x3 grid, you can generate a tree to find out the goal node. So the target node. So whatever the problem you have, that problem defines actually the states which you have, and the return is a solution or a failure. So what we have to do, we have to initialize and then we have a loop. If the frontier is empty, जो जो पहली है वही empty है या उसके further कोई nodes नहीं है, तो फिर हम यहीं पे रुक जाएंगे, ठीक है. और अगर वो nodes हैं, then what we have to do, we have to perform the goal test. So then we have to perform the goal test, and if that node is the target node, why we have to perform the goal test on every sibling? Why? Because we don't know where is the goal state, because these search strategies are also called blind search strategies. We move on to the next level, but we don't know where the target is, where the target node is. So every time when we generate the nodes, what we do, we try to check whether it is the desired state. If it is the desired state, then we will stop over there, and the solution is the sequence of states from the initial node to the that particular node. Otherwise, if the second possibility is that we explored all the tree and we haven't found the solution. So if we haven't found the solution and there is no successor left, then it means you returned a failure. See, that is the concept of tree search. Okay. Acha, now I will share you one thing so that आपको अंदाजा हो जाए. एक minute, just wait a minute. I will share one thing with you, a problem which we will discuss in this chapter. So I have the image of the problem. So I want to share the image of the problem with you people so that you can I hope now you can see the example. I have shared an image of a problem which have been discussed in this chapter as well, in chapter number 3, and various algorithms and strategies have been applied to this problem so that you can understand. By looking into this problem, we can see that it is sort of a network. Can you see this on your screen now? The problem?
Yes, sir.
Okay. So this problem is, you can see, is a sort of a network diagram. And this network diagram is about a country named Romania. Is a famous country, East European country. And in this network, the cities of Romania have been given, and the connectivity of these cities are represented in this diagram. These connectivities represents the road network, how these various cities are interconnected. So the diagram itself represents a sort of a network, and you people know that whenever you have a network and you want to search a particular node, you can convert the network into a tree, because we have to convert this problem into a tree search problem. So by looking into this diagram, we have an idea that how many states are there. For the sake of the example, they are using it. But normally when we are dealing with the problems, we have millions of nodes. We cannot see like this. But since we are explaining the concept of the algorithms and related issues with the algorithms and properties and characteristics of the algorithms. So always in the book, we will see the toy problems, small problems, so that you can comprehend the, uh, the, the core of the topic, and then you apply the same concept onto other to the other problems as well, where you have a bigger state space. Now, what is a state space? State space represents the possible number of nodes in a given problem. This problem, because ये आपको दिखा दी गई है, नजर आ रही है, आप एक आंख से देख सकते हैं, तो आप आराम से मुझे कह सकते हैं कि सर मैं तो काउंट भी कर सकता हूँ 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 and 19. आप कहें सर 19 स्टेट्स हैं, लेकिन when we are dealing with such problems, normally we do not deal with problems where we have 90 states or 900 states. We are dealing with the problem with huge state space. So the same principle will be applied even to a bigger state space. This problem had a smaller state space. Remember this thing. So earlier we have discussed that whenever we go for the tree search, we start from some node that is called the initial node. So in this problem, the algorithm is studied with respect to arith. Arith is considered to be the initial state. Okay, and Bukharest is basically considered to be a goal state. Later we will discuss about it. Right now there is no need of it, but initial state, let's suppose arith is the initial state. So if you start with the arith, you can see the connectivities of arith. What are the successors of arith? If you see the diagram, the successors of arith are Zerend, Timisoara, and Sibui. These are the three successors of arith. So those three nodes will come to the next level. Now, from Zerend, if I ask you what are the successors of Zerend, from Zerend we can go to even arith or Oradia. So there are two connections from Zerend. If you see the Sibui, from Sibui you have four connections. Either you can go to Rimisuvilsia, you can go to Fagaras, you can go to Oradia, and you can go to arith. From Timisoara, you have two connections from arith and Dugots. In that way, what we did, we generate other successors as well. तो हमने पहले लेवल पे सक्सेसर जनरेट किए तो नेक्स्ट नोड्स मिल गई, फिर लीफ नोड्स मिल गई, फिर सक्सेसर जनरेट किए तो नेक्स्ट लीफ नोड मिल गई, so and so on and so forth. We build the tree. So that is the mechanism of developing a tree. But there is one problem normally we have while we converting a network diagram into a tree. That problem is that whenever we do this, we have repeating nodes. Why? Because from arith we can move to Zerend. जब हम Zerend को explore करेंगे, Zerend से फिर arith आ सकते हैं, फिर arith को explore करेंगे, arith से फिर Zerend जा सकते हैं. So whenever we convert the network diagrams to tree structures, normally we have a repeating number of nodes. In the next slide, we will discuss that how how we can solve this problem. What amendment we can do such that we can resolve this issue as well. So we will be considering this problem throughout the chapter. When you see your book, you will find this example over there. But right now, while we are in the online session, so that is why I have shared with you. There is no need to remember everything, just for an idea that we are dealing this problem. Okay. Now coming back to the lecture. Okay. Now coming back to the lecture, the same thing. Now, if I represent this in the form of the tree, what will happen? There is array. From array, there are three successors or three leaf nodes. One is Sibui, second is Timisora, third one is Zarin, which you have also observed in the network diagram, which I have showed you earlier. If you explore further the Sibui, then you have the Arid, Fagaras, Uradia, Rimusu Vilsia. From Timisora, you will have Arid and Lugoj. From Zarin, you have Arid and Uradia. So, as I talked earlier, that you might have the repeating number of nodes. So, how to solve this issue? You can solve this problem by making a small amendment in the algorithm, and that amendment is that you save all the states which are being generated, and whenever you have new states, just compare whether from the new state, is there any state which is already there in your data structure. If it is there, then there is no need to add it. Only new nodes will be added. So in that way, the problem of repeating nodes can be solved while you are converting a tree diagram into, converting the network diagram into the tree structure. So in that way, that tree can be built. Remember that tree is being generated from arid. For example, in the same problem, if I say the initial node is Sibui, then you will your tree will be started from Sibui. So the diagram will be changed. So always it is important that we must have the initial node for any given problem. Now I am switching to the whiteboard, which is used to explain few concepts about a tree. So in any tree, there are important things. Number one, initial node, from where we start our search. तो एक चीज ये important हो गई, that is the important thing. Then we talk about leaf nodes. Leaf nodes, normally called as successors, successor nodes, successor nodes. Okay, we talked about the repeating nodes. Repeating nodes. Repeating nodes cause infinite loop. That is why we handle this problem in a tree. Okay. Now let's suppose I'm interested to know that how many possible number of nodes in a tree. How many possible number of nodes in a tree. That is what I am interested in. So how I can know the possible number of nodes in a tree? So for this purpose, there are two things which are important. One is called branching factor. One is called branching factor. Normally it is represented as B. Sorry, there is some problem with the spelling. I do not mind it because we are using quickly the whiteboard, so sometimes this happens. So branching factor B represents average number of leaf nodes, और चलें इसको आप successors भी कह सकते हैं. ठीक है, that is important. Now let's suppose if I say, if I say the branching factor is 2, what does it mean? Can you respond to me? What does it mean? If I say the branching factor is 2, what does it mean? हाँ, the average leaf nodes are true. ठीक है, कि इसका मतलब है जो लीफ नोड्स हैं या तो वो एक हैं या दो हैं या तीन है, तभी आपने जो एवरेज ली होगी वो 2 आ रही है. अच्छा, लेकिन if I say the tree is a binary tree, then again the branching factor is 2, but in the case of binary tree the branching factor is fixed. It is always 2. Every node will generate 2 nodes. But when I say average branching factor, then it is not necessary that if branching factor is 2 it will be binary. Not necessary. Okay, is that clear? So it means the branching factor might be, it is also possible that branching factor B is might be 4.5. It is possible because we are talking about average branching factor. So average branching factor, it might be 4.5, 5.2, 2.6, 9.8. It can be like this because if we'll not consider the decimal part, then the resulting जो हम approximate कर रहे हैं number of nodes को, वो ठीक नहीं होगा, फिर वो बहुत बड़ा variation आ जाएगा. तो हम, क्योंकि in most of the trees you also observe that the branches are not equal. Sometimes we have 2 branches, sometimes we have 3, sometimes we have 5, sometimes we have 7. So in a tree we have to see the resulting successor nodes, and then we can determine the average. This will help us to approximate the number of nodes in a tree. But only with the branching factor this is not possible. One other thing which is very important for a tree along with the branching factor, that is called depth of a tree. Depth of a tree. Depth of a tree is normally represented as D, or you can say it is the depth of the least cost solution. जहाँ आपको solution मिलता है समझ लें उसकी depth है. Depth of a tree, D. How long you will go downwards, that represents the tree, depth of the tree. Let's suppose if I say that D is equal to 10 and B is equal to 2. How many number of nodes will be generated? Can you respond to me? How many number of nodes will be generated? Can anybody respond to me? How many number of nodes will be generated? Suleiman is saying 22, which is wrong. Anybody else who want to have their opinion? Don't hesitate. I like that Suleiman tried to respond. This is good. Try to respond. Try to think about it. If the branching factor is 2 and depth is 10, how many number of nodes will be generated? Only Suleiman responded. Nobody else responded. Someone else is now Sayyid Azim saying 20. Okay, I can see here. We start with the first node. At that time we have one node. Branching factor is 2. The next leaf node we will be 2 more nodes. In the next we have 2 square. In the next we have 2 cube. Dot 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 plus 2 raised to the power d minus 1. Is it like this? Now you understand the concept. Now it will be 20 or 22 or how many nodes will be there? Now you can understand. कितनी होंगी? this statement is what type of equation is this? Statement is this? This is in mathematics we call it polynomial. तो ये polynomial बन गया ना यार. पहली में एक है, फिर दो है, फिर चार है, फिर आठ है, फिर 16 होंगी, फिर 32 होंगी. तो ये तो बहुत ज्यादा हो गई यार. 20 और 22 से तो कितनी हो जाएंगी तकरीबन? Now you understand the concept. So we can generalize this as well. Instead of writing it 2, we can write 1 plus b plus b cap 2 plus b cap 3 plus dot 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 b cap d minus 1. So can we generalize it like this? So now you can calculate the possible number of nodes if you have the idea of B and D. समझ में आ गया? यहाँ तक बात समझ में आ गई अजीम? अजीम और बाकी क्लास, सब क्लास से पूछ रहा हूँ भाई. You can respond. Okay, good. तो और अब जो बातें आप कॉन्सेप्ट समझ रहे हैं भाई, उसको भूलना नहीं है. There is no time to मतलब है कि रिकॉल इट, बाद में टाइम नहीं मिलेगा आपको. अच्छा, यहाँ पर मैं क्लोज कर रहा हूँ अपना सेशन और मैं 10 मिनट के बाद दोबारा स्टार्ट करूंगा. मैं आपको नेक्स्ट लिंक अभी भेजता हूँ. ठीक है, वेट कीजिएगा, मैं अभी आपको सेंड कर रहा हूँ.